Hello students, this is Sujata Gapre coming with class 10 NCRT SSC Maths with Sujata ji. Let us study the new chapter Circle. These are the topics included in the chapter Circle. First one is the circles passing through 1, 2, 3 points. Second one, secant and tangent. Third one, circles touching each other. Fourth one, inscribe angle and intersected arc. Then arc of a circle, cyclic quadrilateral, second tangent angle theorem, and the last one is that the theorem of intersecting chords. So we can draw the different types of circles. Here see the congruent circles. How can we draw the congruent circles? The circle having the same radii, then we can say that they are called as the congruent circles. So these are the congruent circles. Okay students, having the same radius. Now here also we can draw the different type of circle, that is such a way, and such a circles are known as the concentric circle. Why students these circles called that the concentric circle? Because this circle having the only one center. This smaller circle having this center, and as well as this bigger circle having the same center. So these circles, such a type of the circles are known as the concentric circle students. Then here third way we can draw the intersecting circles students also. That intersecting, there are the two circles and they intersect at 2 points here students. Okay, they intersect at 2 points and so they are called as the intersecting circle. So this way we can draw the different types of the circle: congruent circle, concentric circle and the intersecting circles. Now on the base of the properties of the chord, let us see the three activities here. First activity is, in the adjoining figure, segment DE is a chord of a circle with center C. Segment CF perpendicular segment DE. If diameter of the circle is 20 cm, DE is equal to 16 cm, find CF. So here see the figure student here first, that CF is perpendicular to DE. Here DE is a chord and CF is a perpendicular to this chord. And here the diameter of the circle is given and that is equal to 20 cm. And here also that DE, that is the measure of the chord, is equal to 16 cm. And we have to find out the perpendicular, okay, the measure of the perpendicular, this CF student. So how can we find out this? First we write the given here, okay, from the figure, that is segment DE is a chord, segment CF perpendicular segment DF, DE diameter D is equal to 20 cm, DE is equal to 16 cm, and we have to find out CF, that means CF is equal to question mark. And here now students, at CF perpendicular to DE, then we can use the property of the chord, that the perpendicular drawn from the center to a chord bisect the chord. See here, we draw the perpendicular to the chord, that means the chord bisect. This perpendicular bisect the chord, that means as the measure of the chord DE is equal to 16 cm, that means the segment DF is equal to segment FE and that is equal to 8 cm. Because the measure of the chord is 16 cm and this perpendicular bisect the chord, so that means DF is equal to FE and that means 8 cm. So now here the second part is that the diameter is also given. So from the diameter we can calculate the radius. Diameter is 20 cm. So we can say that radius R is equal to 10 cm here students. Okay. Now here This is a figure, but we cannot prove with the help of this figure. So we construct it that we join the CE. Okay, we join the segment CE. So here, after joining the segment CE, then we have the right angle triangle. As this is the right angle triangle, then we can apply the Pythagoras theorem. So here we apply the Pythagoras theorem. CE square is equal to CF square is plus FE square. Okay. So now here radius, that is CE, that is 10 centimeter, and the chord, that is a half of the chord, that is the FE. FE is the 8 centimeter. So now here that 10 square is equal to CF square, this CF square plus 8 square. So that means 100 is equal to CF square plus 64. So 100 minus 64 is equal to CF square. So 36 is equal to CF square. So CF square is equal to 36 and CF is equal to 6 centimeter. Okay, student? So such a way, by using the property of the chord, we can calculate the measure of the perpendicular student by this activity. Activity student, in the adjoining figure, segment QR is a chord of the circle with center O. P is the midpoint of the chord QR. If QR is equal to 24, OP is equal to 10, find radius of the circle. So observe this figure students. There is a QR is a chord, and OP is given and that is equal to 10. Okay, and QR, that chord is given, that is a 24, and with this information we have find out the radius of the circle. So here first we write down the given. So given is segment QR is a chord, P is the midpoint of chord QR. QR is equal to 24, OP is equal to 10, and radius is equal to question mark. Okay, so now the proof is that here P is the midpoint. The given is that P is the midpoint of the chord QR, and QR is equal to 24, and that means we can say that QP is equal to PR, which is equal to 12, because the half of the chord, that is the 12. Now here we have, that is a OP. OP is the perpendicular, that means we can say OP is the perpendicular. Okay, here OP is the perpendicular, we join OR. As we join OR, then OPR, triangle OPR, this one triangle student, see here, this triangle is a right angle triangle. Okay, after joining the OR. So now we can apply the Pythagoras theorem students here. So OR square is equal to OP square plus PR square. So now here that OR, we don't have the OR, we have to find out OR, that is the radius. Here OP is equal to 12. So here now OP is equal to C students, OP is equal to 10, and PR is equal to 12 students. Okay, that means. So now here OR square is equal to 10 square plus 12 square. That means OR square is equal to 100 plus 144. So OR square is equal to 244. So OR is equal to, in the square root, 244. That means the radius is equal to, in the square root, 244. Third activity student, in the adjoining figure, N is the center of the circle and segment AB is a diameter. Segment MS perpendicular chord AD, segment MT perpendicular chord AC, angle DAB congruent to angle CAB, and we have to prove that chord AD is congruent to chord AC. So now here students, as per stepwise we can solve this activity. So given that M is the center of the circle, segment AB is a diameter, angle DAB is congruent to angle CAB. Now see, that is the proof. That proof is segment AB is a diameter segment AM is equal to segment BM. Okay, AB is a diameter, that means we can say AM is congruent to BM and call it as the first equation. Now here next one, that is the segment MS perpendicular chord AD and segment MD perpendicular chord AC. So that means we can say that angle MSA is equal to angle MTA and call it as the second equation. Now we have the two equations, and here if you see the figure, that in this figure there is, see in this figure there are the two right angle triangles, that is A and S, or we can AMS and AMT are the right angle triangle. And so in this triangle, first we see that side AM common. Okay, side AM is congruent to side AM because these are common sides. Okay, these are the common sides. Second is that angle SAM is congruent to angle TAM because the given. Okay, because given. And then third part is that angle MSA is equal to angle MTA. That means these angles are 90 degree, each of 90 degree. And so now these three parts are congruent. So we can say triangle AMS is congruent to triangle AMT. As these two triangles are congruent, then by CSCT we can say AS side AS is equal to side AT. See here, side AS is equal to side AT. Okay, then we can say that AS is equal to AT, as both the sides multiplying by 2, then 2AS is equal to 2AT, and 2AS, that means AD. So here AD and 280 means the AC. So here AD is equal to AC, and that we have to prove out. That is the chord AD is equal to chord AC. Students, thank you for watching our videos. Achieve your success with us. I am sure that you will get 100% success in maths. So watch our videos continuously, regularly. Like our videos, share our videos to your friends, and also subscribe our videos.